Two quantities or variables are correlated if a change in one quantity affects a change in the other quantity. Medical researchers use statistical inference to decide whether things are associated by looking at whether or not they are correlated with each other. There's a positive correlation if an increase in one accompanies an increase in the other. A negative correlation if an increase in one accompanies a decrease in the other, so opposite directions. Or they're uncorrelated if there's no positive or negative correlation. Correlations in two things are measured by looking at the correlation coefficient for the two things and by graphing the data that corresponds to those things and seeing if there's a strong or weak linear correlation. So if the correlation coefficient for two things is close to -1, then there's a negative correlation between those two things. If it's close to 1, then there's a positive correlation. If it's closer to 0, then there's no correlation. So it goes from -1 to 1. 0 means no correlation. Close to 0 is weak, very weak correlation, but if it's greater than 0.5 or less than -0.5, then there's a strong correlation, either positive or negative. Negative if it's negative, between -0.5 and -1. Positive correlation if it's between 0.5 and 1. So here are some graphs of different examples. So like this first graph is a strong positive correlation because all the data seems to be close to this linear line and increasing. So it's a strong positive correlation. There appears to be somewhat of a positive correlation here, but it's weaker because not all the data is close to the line. Some of it is a little bit ways away from this linear line. So it's not quite as strong a correlation as this one here. Here would be a strong negative correlation because all the data is close to the linear line and it's decreasing, it's going down, so negative correlation. Then we have a weak negative correlation here where the data appears to form a sort of linear relationship, but it's not very close together, so it's weak. And here there's no correlation at all in this data here. So that would be like a correlation coefficient of 0 here. To understand how studying correlation works, we'll look at a few different examples of real data. So this is data collected for Amazon books, paperback books. So we have one variable is the price of a paperback book and the other is the number of pages. So what we want to see is there a correlation in the price of the book and the number of pages for the book? Does the number of pages affect the price? So like would more pages mean that the price of the book will be higher and less pages mean that the price of the book will be lower? So we can compare these two things by finding the correlation coefficient for these two things for the data here, and is not a very strong correlation because it's close to 0. It's closer to 0 than 1 or -1. So we can see here with this graph of the data too that the data is spread out pretty far. It doesn't follow a linear trend. I mean, it kind of does here. So if we didn't have these outliers, then it would look a little more correlated. But these outliers make sense because there are a lot of things that can affect the price of the book. It doesn't necessarily mean more number of pages doesn't necessarily mean that the price is going to be higher. There could be other things that affect, like who the author is or how popular the topic is for the book. So this is an example of two variables that are not very correlated. We have some data for bookstore sales. So one variable is the number of sales, people working in a bookstore, so the number of people that are working, and the other variable is the number of sales. So the question is, are there more sales always when there's more people working? And when we compare these two variables, we see that the correlation coefficient is actually very high, that it does seem to be a strong correlation in the number of people working in bookstores and the amount of sales, since it is almost a +1 here. And we can see from the graph that there does appear to be a linear trend, and we can graph a trend line, and see that there does appear to be a linear trend comparing the number of people working and the sales. So one might be tempted to conclude that if you have more people working in a bookstore, you're going to make more sales. But this is a good example of how correlation doesn't necessarily imply causation. So, for example, there may be more book sales and more people there because it's might be a promotional period or a holiday, so they had to have more people working and we're expecting more sales. So it could be that they just happened to happen at the same time, but one didn't necessarily cause the other. But you can see how the correlation coefficient corresponds to what the graph looks like for the data. It's close to 1. It means that there's going to be a positive correlation between those variables. Another example, fuel efficiency for vehicles that have 6 cylinders. So this one is comparing highway miles to the weight of the car, how many miles per gallon compared to how heavy the vehicle is. Does a more heavy vehicle get less miles per gallon? And does a lighter vehicle get more miles per gallon? And we're just comparing cars that are 6 cylinders. So this is real data. And here we can see from the correlation coefficient that there does appear to be a strong negative correlation in the comparison of these two variables and the graph. Here's what the graph looks like when there's a strong negative correlation. It does appear to have a linear trend, which we can see if we graph the trend line, and negative because it's decreasing. So it actually seems to show that the lighter vehicles can get more miles to the gallon, which is what we might expect. But we also have to realize that these are all 6-cylinder vehicles. Other cylinders, there might be a different result, or other factors like for the vehicle could be affecting the fuel efficiency as well. But we can see from this what it looks like when you have a certain correlation coefficient, how that's going to appear on the graph of the data, and how we can study these things and analyze these things using real data. In these ideas and applying them to the homework assignment, here's the first question. It says, here's a scatter plot for a set of bivariate data, and by that it means 2 variable data. What would you estimate the correlation coefficient to be? So does this appear to be a strong correlation? Does it appear to have a linear trend? Then you would expect it to be close to 1 or -1, and since it's sloping down, then you would expect it to be close to -1. So it might be -0.9 or -0.6. And it is -0.9 because the data does appear to be very close to a linear line. It's all pretty close together, sloping down linearly. Question 2. Match each scatter plot shown below with one of the 4 specified correlations. So we want to decide what would be the correlation coefficient that makes the most sense with each of these graphs. And you should see that some of these appear to be a little more linear, while the others have data spread out more. Like this one looks like it follows a linear trend and negative. So that one's probably this -0.88, which is a strong negative correlation. So that would be B. This one appears to be going positive in the positive direction, but the data is very spread out, so that would have to be either 0.5 or 0.71, and it's probably 0.5 because it's pretty spread out, so it should be closer to 0 than 1. So that was option C. And then here we've got another positive correlation, and it does appear to be more linear than the one we just answered, so that must be the 0.71, so that would be D. And then that leaves us with the last option being A, which makes sense because not very correlated, not very closer to zero than -1, and the data does appear to be sloping down, so A makes sense for this option here. Question 3 is the same idea as question 2. This appears to be linear here, so this must be, and it's going in the positive direction, so it would be the one that's close to +1, so option D, 0.95. This appears to be almost linear here and sloping down, so a negative correlation, so it would be the one that's close to -1, so that's option C. These two do not appear to be linear, but this data does appear to be sloping down here, so this is probably a negative number that's not very close to -1, that's closer to 0, so that's probably A. And then this one here, no correlation at all. This one here that's almost 0 would make sense because it does appear that there's like not really any correlation here at all, so that was B. So that's how you would answer this question. Hopefully all of this helps you see how to complete this homework assignment and better understand how to analyze correlation of two quantities or variables.